All right, good afternoon, class. So last class, in the beginning of the class, we took a class survey where I asked you all to let me know which social media app that you use most frequently, or which one is your favorite, whichever one you chose to do. And you could only select one, and everybody put their stickers up on the board. And again, a little bit to my surprise, nobody actually selected Snapchat, which I did not expect, but according to you guys, that's really not used much anymore. So I learned something there. But the numbers that we got, there were 30 students, and then I included myself as the 31st student. So we're going to say that we surveyed a total of 31 people for this survey. Um, of the 31 students and, oh, excuse me, 30 students and myself, so the 31 people in the survey, um, the number of Instagram users was 12. So we'll write that in there. The number of TikTok users was 14. So those were pretty close. 4 people selected other, meaning they either don't really use social media or some other platform that wasn't listed. Nobody selected Twitter. Nobody selected Snapchat. And because I'm old, I selected Facebook. So there was one there. So this is our survey results. So you can go ahead and fill those in. And what we're going to do is we're going to talk a lot about how this stuff works with probabilities. So we took a survey of 31 people. We have the results. We're going to use those results. So there is a lot of vocabulary in this particular unit. So we're going to have to make sure we go through this stuff. Something which is called a probability experiment. Okay, so what we just did was the basis of an experiment. I took a random survey. So we're going to define probability experiment as as randomly selecting a student from this class, student and or teacher, I guess, if you want to include me, and asking him or her or them which social media app they use most frequently. So we did that. A thing which is called a sample space is basically just listing out all of the possible outcomes that we could have. So that's what's called your sample space. So in this case, our sample space was, if I'm remembering correctly, it was, and it does not have to be in any particular order, Instagram, Facebook, X or Twitter, Snapchat, TikTok, or other. 1, 2, 3, 4, 5, 6. Yeah, we had 6 categories. So that's your sample space. And that's all that a sample space is. It literally is just a list of all the possible things that we could have had in the survey. Okay, so that's what a sample space is. And that was our sample space. Now let's talk about the events that happen and what their probabilities are. So an event can be a single outcome, one potential outcome, or a combination of outcomes in a probability experiment. So to find the probability of some kind of an event, and we'll call that event A for now, usually you put something in there where A is. It's denoted as P parentheses A. So it kind of looks like multiplication, but when you're dealing with probabilities, it's not. It's the probability of A happening. So ultimately, it's just simply the number of outcomes that make up event A divided by the total number of outcomes. It's really, really simple thing to do. Probabilities can be expressed in several ways. You can do it as a fraction, which is what we'll start with. You can do it as a decimal, assuming that the decimal works out nicely. Or you can do it as a percentage, and that's just multiplying the decimal by 100. We've dealt with that several times already when we were dealing with exponential growth and decay models. So in ours, we're going to ask ourselves how many students reported TikTok as their favorite social media app. And if you go back to the first page, the number of TikTok users was simply 14. Okay, that is not asking us for the probability. That is asking us just how many there were. So we had 14. Now, if a student is randomly selected from the class, what is the probability that the student will report TikTok as their preferred app? So we want to make sure we write this correctly. So the probability of that event, so we're going to say the probability, and we'll say TikTok. The probability that we select a student that had TikTok is going to be however many students selected TikTok, which is 14, divided by the total number of people in the survey, which in our case was 31. Okay, and there is no need to reduce anything. Now that doesn't reduce anyway, but there's no need to reduce that. It actually helps not to. If you wanted to figure out what the decimal of that was, you would just simply do 14 divided by 31 and see what that gives you. And in the calculator, that gives us approximately, approximately 0.45. I'm going to round the next one to 2, 0.452. Or we could say as a percentage, if we multiply that by 100, move the decimal 2 places to the right, 45, man, my fives are not good here, 45.2%. So not quite half the class, but almost half of the class selected TikTok. The probability of us selecting at random, so somebody just comes in and throws, like everybody gets assigned a number and somebody just throws out a number, says number 32, or not 32 because we didn't have that many, number 16, whoever number 16 was, the probability of that person being a person who selected TikTok is about 45%, or 14 out of 31. Okay, hopefully that is hopefully that's okay for everybody. So let's now talk about this thing which is called the complement of an event. Okay, complement, notice that that is not spelled like the compliment that you would actually give to somebody because you're trying to tell them they look good or something like that. It's spelled a little bit differently. The complement of an event is basically the probability that something doesn't happen, or that probability that the event doesn't occur. And the way we denote that is with this little symbol right here. It looks kind of like a little squiggly line. I believe it's called a tilde in the Spanish language. Or you can do A with a little c almost as an exponent, which just indicates it's a complement. So it kind of looks like it's written as an exponent there. Both of those two things basically mean what is the probability that that event did not happen. So the idea is, if we know how many people selected TikTok, we're going to look for how many people were left over in the entire thing, or how many people did not select TikTok. So that's everybody that's left. Well, there were 31 people, and if 14 people selected TikTok, that means that 17 did not select TikTok. And that would be that little tilde A, or A with the C raised as an exponent kind of a thing. So what is the probability a randomly selected student would not choose TikTok as their preference? Well, how would you do that? You would do it as the probability of not TikTok. And of course, that would be everybody that's left, which is 17 out of the total people that were surveyed, which is 31. So we're going to compare the answers from 2B and 3B and see if we can figure out anything that's kind of important. How are we going to write a rule for computing the probability of not A? I've already kind of said it. So the answer from the probability of A, or the probability of TikTok, I'm just going to, I'll just put the probability of TikTok in here, was 14 out of 31. The probability of not TikTok was 17 out of 31. So basically, how are we going to get that if we have to look at it? Well, the idea is if we take the total number of people, which was 31 out of 31, and we subtract the 17, I'm sorry, put that on the wrong place. We take the 31 out of 31 people and we subtract the 14 out of 31 people, we then get the 17 out of 31 people. So the idea is that we take the entire number and subtract the amount of TikTok users, we'll get the amount that did not select TikTok. Okay, again, I hope that that makes general sense. I'm kind of going a little bit more into depth here just to make sure, but I think that that probably makes sense to most people. All right, so now we're going to talk about this thing which is called a probability distribution. And yes, we are going to go through all this stuff relatively quickly. So if you need to, because this actually will be on YouTube and you'll have a link to it, you can always go back and watch it again and slow it down if it's going a little too fast. So a probability distribution lists all the outcomes in a probability experiment along with their probabilities. So you can see across the top of this little bar here, it's got all of our outcomes: Instagram, Facebook, TikTok, so on. But now we want to create the probability distribution for the results of the class survey. So we're going to take basically all of these outcomes, and we're going to state what their probabilities are. So Instagram had 12 people select it. So that would be a probability of 12 out of 31. Okay, Facebook, because I selected it, would be 1 out of the 31. TikTok, which we've just been dealing with, was 14 out of the 31. Snapchat had 0 out of 31. And X and Twitter had 0 out of 31. And then the other category had 4 out of 31. So in part B, it says if the probability distribution includes all the possible outcomes of the probability experiment, what would you expect the sum of the probabilities to be? Again, think about that. If it's got to include every possible outcome in the probability experiment, if you add them all up, what would you expect the total to be? Well, I hope that you would expect if you added them all up, you would get 31 out of 31. And that is true, because if you take 12 plus 1, that's 13, plus the 14 from TikTok, that's 27. Nothing in Snapchat or Twitter, so we're still at 27, but then plus 4 more out of the other categories, so you are at 31 out of 31. And of course, 31 over 31 simplifies to 1, which as a percentage is 100%. So that should make sense. We've added them all up. We've got 100% of the possible results because we had a survey, and you have to basically consider that if you add everything up, you should get 100% of your results. So S is going to represent the sample space. So capital S represents the sample space, which is certain to occur. So what is the probability of S? So again, that is just literally asking us, what is the probability of getting some result from our sample space? Well, considering you have to get something out of your sample space, the probability that we get something out of our sample space, is 1. Okay, you have to get a result out of your sample space. That's all you can do, because that's part of our survey. So the probability of getting some kind of an event that happens out of your sample space is 1. Has to be. And if you're thinking ahead, all the other probabilities that are inside there have to add up to 1. So all of those numbers are going to be something in between 0 and 1, because the probability of getting Snapchat or Twitter was 0. Okay, we had 0 people that said that. So that probability is 0. But all the other ones have to add up to equal 1. Okay, so we're going to talk about what's simple versus a compound probability. The ones we've been doing have been simple. A simple probability refers to the probability of a single event, one thing happening. So the probability that A happens, or in our case, the probability that TikTok happens, or in some other survey or something, the probability that you might be late to work. One simple event, one single event. A compound probability refers to a probability of more than one event, typically combined with words like and, or, and given. So you could have something that looks like the probability of A and B happening, which means that, and I'm sorry, because this thing kind of shifted here. The probability that people like TikTok and Facebook. You have two options. You might be able to select more than one thing. So it's the probability that two different things happen. Or you could have the probability that you like either Instagram or Facebook. So you either like one or the other. You don't have to like both, but how many people might actually like one or the other one? And then the way the last one is, and again, I apologize because it kind of shifted on me on this thing. Hopefully it's better on your paper. The probability that you're late, given that you might have overslept. And you would probably expect that that probability might go up. The probability that you're late, given that you overslept. That's a slightly more complicated one for us to do, but we will figure those out as we get to them. So let's talk first about the and statement. Since each student could select only one option in our survey that we did, the events in this table are considered disjoint, also known as mutually exclusive. You are definitely going to need to know those vocabulary words. And the reason they're called disjoint or mutually exclusive is because they don't share any outcomes. So in our case, I did not allow you guys to select more than one. So there is no way that you could have selected two different things in our probability experiment. So all of the outcomes, Facebook, Twitter, Snapchat, all that stuff, it's mutually exclusive. It's disjoint. You could only have one. You could not have both or several. So for our example, again, it was only possible to select one thing. So what's the probability that a randomly selected student chooses both Instagram and Facebook? Well, since I only allowed you to select one, the probability of you selecting both is 0. There was no way for you to do that. Okay, in your head, you might have thought, well, I like both things or whatever, but in this case, there was no way for you to do it because I only allowed you to select one thing. So that probability is 0. There was no way for you to have both of them at the same time. Okay, and that's an and statement. For an and statement, you've got to be able to include both things at the same time. I'm actually going to show this when we get to the last couple of pages here in a diagram, and hopefully that'll make things make a little more sense. The or statement. This one's a little bit more tricky for a lot of people to understand, but in general, it's not that bad. Suppose you want to determine the probability that a randomly selected student would choose Instagram or other. So a big difference here in the word or as opposed to and. Since the two events are disjoint, we can just add the probabilities together. In other words, if you look back at the chart, the number of people that selected Instagram was 12 out of 31. The people that selected other was 4 out of 31. So the probability that somebody selected one or the other one, they don't have to have selected both, just one or the other, ends up being 16 people out of the 31. And again, I hope that that makes some kind of sense. So if it's only one or the other, you add them up. If it's one and another one, then they both have to have been selected. And there's no way for one person to have done that. So the and statement was 0 in this case. The or statement, we can add the probabilities together. And again, that's because they are mutually exclusive or disjoint. Oops, did I skip? No, I did not skip a page. Okay, so I'm gonna go ahead and cut this video off right here. I'll come back with a second video, which will do a little bit more explaining about diagrams and stuff like that. and it's going to give us a different way of looking at it. It's a survey that unfortunately I did not get to do in the class, so I'm going to make the numbers up, but we'll see how it works.